Unit 17 is called calculator questions. So now it's nothing new, it's just how to use a calculator to do what we've been doing with derivatives and with antiderivatives. So lesson 17.1 is tangent line equations with a calculator. It says the function f is defined by f of x equals x squared minus 4 plus 4 sine of 2x. So this equation that is really a polynomial. It says use a calculator to write the equation of the line tangent to the graph of f when x equals 1. You should round all decimals to 3 places. You will not have a graph, but I included a picture just so you have a visual of what you're trying to do. You're trying to figure out at x equals 1, what would be the equation of the line that's tangent. So you're trying to figure out first what the y value is at 1, and then to write the equation of the line tangent there. And so this is just kind of an approximation of what maybe it would be. Sorry, that's off a little bit. But either way, I know my slope should be negative because it's decreasing. And so what you would want to do is to first put in the function. So you go to y equals, clear out anything if you have it in there, x squared minus 4 plus 4 sine of 2x, and close the parentheses. A couple things you might want to check before you go to graph. Go to window. Mine's just set to the normal. Negative 10 to 10 is my x's counting by 1, and negative 10 to 10 for my y's counting by 1. If yours doesn't do that, you can change by hand, or you could go zoom and hit number 6. 6 will automatically change it to be the standard window. It to graph it for you. So this is a way that you go ahead and figure out when x is 1, what is y? So 1 comma what? And it's probably going to be a decimal that needs to be rounded, but let's see. So I'm going to go second calc, or the trace button, and I'm just going to find a value. So hit enter. This allows you to type in any x value. So I want to do 1, hit enter, and it will come up with the y value at that given x value. Okay, so I'm going to round to 0.637. So there's my x, there's my y. Then I need a slope. I need the slope of the tangent line at 1. So there's a couple different ways you could do this. I want to show you your options because sometimes I like to switch between them depending on what I need. First thing you could do is go back to your y equals, and we're going to do the derivative of this function. So you want to hit math, which is right here, third button down, math, and then go down to option number 8. So in the future, I'll just hit 8, and I know that's derivative. It says in derive. So I'm going to hit enter, and it comes up with this. So I want d over dx. And then I could type this whole function in again, but to save you time, what you can do is go to vars, that's for variables, and then over to y vars, so y variables, and then hit enter on number 1 function, and then enter again to select y1. What that allows me to do is take whatever equation was in for y1 and actually put it in right here. And so it saves a lot of time once you get used to where that's at. And then you just want to put x is equal to x. You don't want to put a number. So that's going to graph the derivative of this function. It's going to literally take all the slopes at each of these individual points and make it into a function. It takes a little bit of time for your calculator normally to graph it. And so what I'm going to do so it doesn't confuse me is I'm going to actually take off the first graph. And you can do that by going over the equal sign and hitting enter, and see how now the equal sign is not highlighted like it is on Y2. So that'll just graph this. So I'm going to hit graph. Like I said, it kind of takes a little bit to load. It takes your calculator a little bit of time to think about how to graph it. So again, this is the f prime graph, or the derivative graph. So it shows you where slopes are positive. It shows you where slopes are negative. The x-intercepts are where slopes are 0. Okay, so it's done graphing. Now what I want to do is find the slope at x equals 1. So I can do the same thing where I go second calc value, which was number 1, and I want to figure out at x is 1, what is y, because that's the slope. It is negative 1.329. I now have everything I need to write my equation. Remember, point slope form goes y minus y1 equals m times x minus x1. And you can just leave it in that form. So it'll go y minus my y value, which is 0.637, equals my slope, which is negative 1.329, times x minus, and I already knew my x value was just 1. Now I'm going to show you another option if you didn't care about the graph. So second quit out of that, what you could do is go ahead and go math, and remember option number 8 down here is derivative, so I'm going to just hit 8, pops up with this. We're going to do d over dx, so the derivative of, again, I could either put this whole thing in the parentheses, or I could go vars for variables, over to y variables again, enter on function, enter y1. And I would have to have, remember, this put in for y1 to be able to use it. And so that allows me to simply put that in there. And then now I can pick a specific x value. So I want the derivative of this function at x is 1. And then hit enter, and it'll give me this same number that I calculated here. So those are your two options, whichever you prefer. And again, this matches up because my slope is negative, just like I said it should be.